All right, hi. I thought I'd cover some more general problem solving techniques for programming that aren't necessarily Unity or even really C Sharp specific, but there are some things I also want to talk about that are more Unity specific. And I have a list here of just kind of things to go over. Oh, it's like infinite. Um, it's going to be focused on C Sharp and Unity as context, but all these are pretty general. The first thing is like this a lot of helpful tools. I'm just always thinking of tools like using tutorial videos to figure out how to do stuff is good in the beginning, but I think it's also good to know like other ways and how to kind of extend outside of that, sort of start like figuring stuff out more organically and having more agency over that. And the first tool I want to go over, just because it's the funniest tool that I genuinely use all the time, is MS Paint. It's more helpful than you would think, though it's also very situational. So in general, like a lot of problem solving with programming isn't necessarily going to happen in your code editor. So a lot of it can happen, like say you have, in the best use case I can think of MS Paint, just off the top of my head though, say you have, you're trying to do some vector math. You have your little player capsule, right? You draw them out. This is your player. And you want to figure out, all right, so they're facing this way, you know this direction. Let me do in red. You have this direction vector, right, of their forward, right? This is the way they're facing. Lies. So you know this is their forward, and then you have, say, like, you want to figure out, like, how do I get, we have their, say they're on a ground that's sloped like this or something. You want to figure out, like, oh, so we know this vector is like this. We can kind of simulate little basic game situations. We can say, okay, so we have these two vectors, so then we can kind of draw that, like, oh, so we have this, and then we have this direction vector because their position doesn't matter. So we know we have something that's a different color, but it's fine. And so like, oh, so okay, so we can look at this and we can say, okay, so what's the dot here? Like we can figure out like, oh, so the dot product, and we can kind of sketch that out. So it would be, this is the angle. This would probably be about, that's 90 degrees. Maybe 1, that'd be 0. This would be like maybe negative 0, because these would be normalized. Yeah, I don't have to worry too much about this. So we have like, oh, so we can figure out this is a dot of 0.2. And then you can keep doing vector math kind of by hand, figuring stuff out, and you can use MS Paint for that a lot just to visualize stuff. That's kind of one common use case that's really helpful. And then you would actually go into the engine and you'd be like, okay, so then we can use like, oh, so we know like we're going to be getting a negative dot if it's sloped back and a positive dot if it's sloped forward, and we can kind of figure stuff out. So you can do stuff like that. Like it's really good for vector math. It's also really good for array stuff. We should start with that one. It's a bit simpler. Sorry, why are you doing the thing? There we go. So say you're like, for example, say you're trying to figure out how to convert like, a 2D array of like, this. This is one of the things I used for when I was making like a level editor. So, we have, oh, so we know, this is 0, 0, 0, 1, 0, 2, 0, and so on. This would be 1, 0, 2, 0, and so on. We can figure out, we can draw, I draw that, it's not the main numbers. This is 1, 1, 2, 2, 2, 1. I messed this up. Hold on. 1, 0, 2, 0, 2, 2, 1, 1, 1, 2, 2, 1. There you go. I think that's right. So be like, okay, we have all these coordinates, then you have like, okay, so we want to convert this to an array. You can then draw it out, and you would draw all the 9 sections, or whatever, and then it would be like 0, 1, 2, 3, 4, 5, 6, 7. Probably draw it a little bit neater. 8, 9. And then you can try to figure like, okay, so if we want this to go here, here, you can kind of like draw stuff out. It's really good for drawing out like things like this, like things that you can visualize. In this way you don't have to like try to keep it all in your head. It's good for just a lot of visualization, basically in general. The next tool I'd want to go over is one you're probably familiar with. It's on Chrome. For UML mapping, Gitmind is what I usually use personally. I have probably a lot on here. Some other things in here too. I don't think I have any UML mapping things. Let's just do a new. You probably want to do a new flowchart. And then yeah, you obviously have UML. In general, any tool, there's a lot of tools I can use. Any tool that just lets you put boxes, and then you can be like, oh, this is this class, this is, my class. And you can put your variables and stuff. I think there's actually ones that have all that stuff and it kind of has it formatted. So tools like this are really good for code architecture. There's also Miro, which can be really good, which is kind of like a virtual whiteboard. These tools are really good for planning out your architecture, maybe not specifically like how your code's going to work, but just how like you want to kind of plan it out, how you want your interfaces to be, and how you want your inheritance to be, and all that kind of stuff. Miro or Getmine. There's other ones too. This is a pretty common type of tool to find. Another one is of course Notepad. For stuff like this, just in general, like say you want to figure out an algorithm, right? You have like, say you have that 3-dimensional array, right? Or 2-dimensional array you want to turn into a 1D array, or let's do the 1D to 2D. So we kind of have that drawn. So you'd be like, okay, so, how do you do that step by step? Define dimensions, or I guess it'd be really define, because basically when you look at it like this, it's like, oh, you're basically slicing it up. So you could so you're like, oh, you're slicing it, here and here, and then kind of stacking them over. So when you think of it like that, you can be like, oh, you can visualize that and kind of see that. So you can be like, oh, okay, so, I need to figure out the width of the new one. Width of 2D array. And then you have to figure out like, okay, we can use that width to then go through, loop through, and make new, or, well, no, then I have to do create a double array of with width divided by, or be contents divided by width. And then, so you do that, and then you would do, for, what would it be? In this case, it's 3, but in general, it would be for each array, and in that case, it'd be for each create a new array with how much would the contents be? With content with a length of width. So the length would become the width, and then loop through 1D array, and every increment, every time you surpass width, fill next array. The array filling every time you surpass the width. So like every time you do 1, 2, 3, 1, 2, 3, 1, 2, 3. So you can kind of use it like that. And it's similar to visual, but it's also just another way to do that. You can also just use your code editor and comments to do this. Though it can be nice to do it in Notepad just to like not have to think about like, oh, I have this class here. Like it kind of simplifies it. You're just looking at like, usually you wouldn't have all this stuff. So you just be looking at like, do it more. There you go. You just be looking at like a blank screen. You're like, oh, it kind of helps like just reduce like the cognitive load of just looking at all your code all the time. Next thing is looking at documentation. So say you're trying to figure out like, oh, how do I don't know, enums work or something. Just look up C# enums and find, in this case, it'd probably be Microsoft. And look at like, oh, most things are decently well documented. You can just kind of look at them and be like, oh, that's how they work. And kind of read through, and there's links to other stuff if you need more information. So just learning how to read documentation, look at the documentation is also really helpful. Same goes for Unity documentation. If you're like, oh, Unity line renderer, it'll be in the manual. Sometimes it'll be outdated. It can vary. Different components, different things, and are always going to have varying levels of documentation. But you can read through, and it'll usually tell you a lot about it, or offer you links to other things, and there's just a lot of information. A lot of information in this case. In general, a lot of things documented. A lot of tools, even like if you just download something from like GitHub, probably will have documentation on there usually. Um, I don't use external tools a whole lot, but from what I've seen. Where's my notepad? There it is. What's going on my 10 minutes? Debugging. So Stack Overflow and forums in general are really good for debugging. That's usually how I end up using them. If you say are just having a small issue that you just can't understand, try to like look up, try to like simplify the situation and look it up. And be like, oh, why can't I assign, an int to my double or whatever weird thing it is. Like you can kind of look into it. Forums are really good for small bite-sized issues because that's usually what I post to them. Both, just looking for a post, and you can also make your own posts. I really haven't done that, but that's also an option. Just make an account and start making your own posts when you're confused. Another good thing is video tutorials. It's not good to rely on them and to be like sort of limited by what they cover, but it is good to use them as a starting point if you're just completely lost on something, or if you just don't know, if you just need a starting point on how to do something. They can be really helpful. I think I just kind of watched like the Bracky's tutorial on like turn-based combat a while ago to figure out how to do state. I was like, oh, it's a state machine. Like we watched that and you figure out, oh, he's talking about a state machine. Then you look up state machines and you get more on that. And it brings me into my sixth point of how to kind of figure out complex algorithms. For example, A star JPS, right? If I look up A star, which is like a pathfinding algorithm, A star JPS, which that's an optimized version of one. You'll find Wikipedia articles usually about these type of algorithms. You'll find, blog posts. You can find all sorts of stuff. There's like papers on these things, in this post. There's all sorts of information on these algorithms that's external. Like this is not like this. This is a whole thing where you can visualize it and it demos it. It's a whole thing about this. You can actually do this. And I'll show you. Oh, this is it without JPS. I use this a lot for figuring out JPS and A star. You say, oh, it makes sense. It takes forever. Then you turn on JPS and find path, and so it allows you to see like a lot about how these algorithms work, and you can just find information. And that's like, once again, this doesn't rely on any one language because a lot of algorithms in general aren't really language specific. It's just like a concept, right? It's just kind of how a thing works. And then usually there'll be notes or there'll be something you can usually find. Usually original research paper. You can read through this, and this will be like the actual thing. The really nerdy thing where I'll explain it. I'll be like, actually, it has very similar visualizations. It talks about like forced neighbors, and all sorts of stuff, jump points. Like this will go in detail about this stuff. Give you all sorts of stuff, an almost overwhelming amount of stuff. So this can be a very good starting point. Just read through and just try to understand. And another good way to understand is to just kind of like read through, look at some things, even look at some videos, and then just try to like implement these kind of things for yourself. And then don't expect it might not work the first time you try to implement something like this. And then just kind of keep trial and error it, checking back to the papers until you kind of start to understand and get it. Over time, you'll sort of understand it more and more as you work with it. Some other notes and just helpful concepts, and is that in general, nothing is magical. Like everything, and even Unity is built on code. A lot of it is C#. So a lot of it is also C++. Like I think there's a lot of extern calls to C++ stuff. But for the most part, it's all C#. In Unity, all component variables are invisible in the inspector, can be also interacted with the code. So if you go to create empty add component line renderer, that's a really good one to kind of show off. Let's add just a material over here. Here we go, materials. That works. So you can see, oh, we have this line renderer here, right? And we can change, for example, positions. We make this to like 1, and this one to -10, and we get this big line, and we can add like 3, and then we can, not that many, 3. Then we can make this one like 0 and 8 or something, and So you see we have all these parameters here, but you can absolutely access all of these through code as well. Like all these are also accessible on, C#. Like I could probably, let's just confirm this, right? Line rend test. So I'm making a C# script. To load, it should be a mono behavior by default. It's loading. So students start. So we can do, private line renderer rend equals, game object dot equals add component. I think it's just game object. Do add component, does assume add component. Line renderer. Okay. I'm ready to get yourself this dot game object. I shouldn't need to do that. Oh, yeah. Game object dot add component, add component. There you go. So we have the line render, and so we should be able to do rend dot. So we can find here we have. Let's see. We have positions and size. So we have positions, an array of vector 3. So we should be able to come in here and do positions count equals, say, 3. I'm assuming that's the same. Sometimes they're named differently. Or named a little bit weird. So we have positions count, and then we have rend dot. We should also have one that is like positions or something, or set positions. And here we go. So we can set. So now what we can actually do here is we can just recreate this, right? We can do like 0. So we can do index 0, and then what do we have here? Oops, wrong thing. We have 1 0 0. Why did you not like that? Oh, yeah, because I made my own. So it's thinking it's that one for some reason. So I have to specify. There we go. And we can go through, do the other 2. So it's -10. Eight. I know this is 8. Right. 0. Right. And now if we run this, we should basically get the same thing, except I think it won't have a material, but it'll be the same thing. So what we can do, we can basically, instead of putting this on, we can put on, this thing we just made. It should basically create that same thing, but just purple, magenta-ish, in theory. Oh, wait, I think I have to actually delete the line render because it's a component. I think just gonna add it. Here, let me remove, create empty, do this. Oh, did I not? Yeah, I think I just couldn't add it, so it bugged out. Right, let's try this. There you go. So you see, same thing, like if I just take this, I can literally just like, I guess I position it slightly differently. That's kind of weird. Maybe I just put the numbers in wrong. But yeah, you see, you basically have access to all the same things. Oh, I don't know why it's displaying it differently. But you can see like it's set through. So you're always going to have access to all. I've never come into a situation where like it just didn't have one of the variables it had over here. These are always accessible through code. Another thing is an algorithm is not code. Basically just saying that like the concept of an algorithm, in this case a very complicated one, but even like of a simple algorithm of like just moving an array like this, has nothing to do with programming itself. It's just the concept of moving stuff. They're usually not language specific, and it can be very helpful to abstract this from the actual like code implementation over here. You know what I mean? Like this is separate from your little code stuff that does it. Basically, an algorithm is an abstract representation of. Well, I mean, it can depend. It can also be this, but it can be a good idea to abstract your algorithm away from just being code into being like an actual just conceptual set of steps. And that can be really helpful in just understanding what you're doing and explaining it just to other people. That's sort of what this paper over here is doing. It's abstracting and explaining it. So just kind of keeping in mind that like they're not the same. Like an algorithm is not inherently code, and also it can be really helpful to separate them and to like focus on the algorithm before doing it, especially if it's more complicated. Next note is the rubber duck method, something I was told about by Tucker. And basically, if I can spell, it's basically where you go through your code step by step and just like say it out loud. Usually to a rubber duck is kind of the idea. So you would just go through, like, say you have like this line of code here, and you say, oh, so first, I'm in start, so this runs right when the object is created. Then I create a new line renderer component and I create a new reference to a line render component, and then I set that to a newly added component to the game object of a line renderer. And then I set the line renderer's reference to this position count to 3, and then I set the first position in that array to vector 3.1, and then I set the second position to, this vector 3 negative 10 0 1. Then I set the third position to 1 0 8, and you just keep going through and you're talking about that. It's really good for debugging. That's kind of the idea. It's sort of like there's other ways you can debug, right? You can like do breakpoints and stuff, but it's sort of a way to just like talk yourself through your code step by step and just figure out why it's not working. It can be a good method for debugging. And the final thing is just like, just take naps. Like if you're like staying up late trying to program something, especially something complicated, and you're tired, at least from my experience, I always get tunnel visioned, like really tunnel visioned, and just am working at basically nothing. So I'll stay up like 2 hours working on something, like two hours into the night, more than I want to, like working on something, trying to get something to work, and then it just doesn't work, and I wake up the next day and I just immediately know how to fix it because I'm like, I've slept and I have sleep, and I'm not getting like super tunnel vision, because it's always like you get tired and you just keep thinking like, oh, this exact way will have to work. Like, I just have to keep tweaking it, this way will work, and it just keeps getting more and more weird and nonsensical until you just give up. So it can be really good if you're feeling tired and you're not really making any much forward progress to just like, even if you are just tired and you're not making progress, to just like take a nap, get some sleep. Yeah, but in general, I think in summary, like there's a lot of tools to use for figuring stuff out besides video tutorials. I think the best two are MS Paint and Notepad. Things that are just like very simple. Like there's a lot of utility to something that like MS Paint where it's just like really simple, just a blank canvas. Same with Notepad where it's like, it's not some big complicated thing. You're just like, I don't know, it's a cube. And you can just do whatever, and you can just figure out like things more conceptually. I gotta draw the cube. I don't know what happened here. Don't worry about it. But yeah. So MS Paint. It's just weird how MS Paint's helpful. Feels kind of cursed, but yes. I don't remember if there's something else. No, yeah. I think MS Paint, Notepad are helpful for figuring stuff out that you kind of think like if you feel like, oh, I kind of know this, but I don't fully, like, you just want to kind of like concretely describe it. They're really good. If you're just super lost, video tutorials can be good as a starting point, which then you can kind of move into, other stuff like using papers if it's something complicated, or just using like Stack Overflow and other forums if it's something that's just like a little thing. Yeah, and also it's good to keep in mind code architecture, and there's tools that can help you with that, like Mirror or Gitmind, and then just, yeah,